Hey, how we doing today, guys? Today we're going to take a look at using machines. So we're going to take a look at simple machines and how what we've been studying so far in this unit of energy applies to them. So grab your notebooks. We're going to record this in the input side of our notebooks so we can work on an output activity here in just a little bit as soon as this presentation is finished. So for today, our first question, our essential question for today. What are some machines we use every day to help make doing work easier? Well, we're going to be able to answer that question by the time we're done with this activity today. All right. Okay, so we're taking a look at using machines today. That is the title of our notes today, using machines. And what is a machine? Here's the first definition we have. A machine, or simple machine, is a device that makes doing work easier. Okay? Does it say it changes the amount of work being done? No, it just makes doing work easier. Well, how does that happen? Well, here's our next sentence. Machines make work easier by increasing the force that can be applied to an object. All right, here's how this works. There are two forces that are involved when a machine does work. We have the input force, that's the force that we put into the machine, or the force applied to the machine. In this little picture here, it's the effort force, the amount of effort going into the machine. That's the input force. And we have the output force. Output force is the force applied by the machine. Now, I like to remember this as fin and fout. That's just kind of the one thing that works for me. When we look at the output force over here, we've got a load of 50 newtons that is being done by the machine. So the input or effort force was only 12.5 newtons, but the machine increased that by how much? Let's see here. It's almost by 3 times as much. A little bit more than that. Okay, by 3 times as much. So the hammer is able to increase the amount of work being done. Not really increase the amount of work being done, sorry. It increases the amount of force being exerted by changing the distance here. Okay, see how we're changing the distance? How much distance there was on the hammer itself, it's a lever, was 0.28 meters. And then there's just a real short distance between this part of it and the load that's being lifted. In this case, it is a nail that's being pulled out of a board. So this hammer claw, the claw part of the hammer, didn't really change the amount of work being done, but it made it a lot easier than if we were just to try to pull on that nail with our fingers. So the hammer itself is a lever, it's a simple machine. It made work easier by increasing the amount of force we put into it so that it gave a nice output force. Okay. What we're going to take a look at today and maybe tomorrow is mechanical advantage and efficiency. These are two calculations. I know, guys, more math. We love math, don't we? Mechanical advantage is the ratio, or it's going to be, we're going to divide one thing by another, the ratio of the output force to the input force. Okay, so here's our formula. Mechanical advantage is equal to output force, which is measured in newtons, divided by the input force measured in newtons. And the formula here, we've got mechanical advantage, MA, equals force out, or FOUT, divided by force in, fin. And mechanical advantage is one of those quantities, because it's a ratio of one force over another, it does not have any units, okay? Because we've got newtons divided by newtons, those newtons cancel out. So mechanical advantage has no units. Yay, that's one thing we don't have to remember. Okay, next we have efficiency. Efficiency. So if we were to ask ourselves a question, how efficient am I when it comes to doing my work? we would have to take a look at this. We would have to ask ourselves of a measure of how much work we put into it is changed into useful output work by the machine. Now, efficiency is different from mechanical advantage. Mechanical advantage tells us theoretically the advantage of using a machine compared to what goes in and what comes out. Efficiency measures how much work put into it compared to how much work comes out. And machines can be made more efficient by reducing friction. This is true because as automobiles were invented and things like that, and engines and stuff, they used to just kind of let them go, and because the parts, they would just move, and as much force as they could get out of them, that's what they would do. And then they started realizing that if wait a minute, if we oil the machine, if we put oil on it so that the metal parts could slide past each other and reduce friction, then it became more efficient. The machine ran better. Okay, so that's why it's so important for us to make sure that our cars have oil in them on a regular basis, because it'll reduce that friction. If friction builds up too much in your car, what could happen is it would heat up so much that the metal will fuse together. And one time I actually did that. It was pretty embarrassing, and it was really bad for the car. It had to have a new engine. So I really messed up the efficiency of that car. I made it so that it wouldn't run at all. Hopefully you guys never do that. It's bad. Just make sure you put oil in your car so that it runs as efficiently as it possibly can. Okay, in a couple of days, we're going to take a look at mechanical advantage and efficiency, and we're going to do the math with that. But that's all for our notes for today. This was short and sweet. We're going to go ahead and move to the back of the room and see what kind of output activity we have next. Pay attention to your instructions and get it all done, guys. See you next time.